our regular program with breaking news. Urine odor alert. Could it be Hawkinsinuria? Let's go live to our health correspondent for more details.
I'm Afra, going to start with the history of Hawkinsinuria. So based on this clinical history of Hawkinsinuria as outlined in the picture from the referred articles. So Hawkinsinuria was first discovered in 1975 by the Dungs when they identified a new form of the transient tyrosinemia that categorized by the self-metabolic acidosis in a baby. So this disorder was found to be caused by a deficiency in 4-hydroxyphenylpyruvate deoxygenase, HPD, an enzyme that involved in the tyrosine metabolism. So these clinical investigations revealed that affected individuals typically presented with the metabolic acidosis, transient tyrosinemia, and the excretions of an unusual sulfur-containing amino acid that named Hawkinsin. The disorder was noted for its autosomal dominant inherited pattern, meaning a single copy of the altered gene in each cell is sufficient to cause the conditions. So in this case, pathogenic variants in the HPD gene were identified, confirming the enzyme deficiency observed. So this clinical history for the management of Hawkinsinuria typically involve dietary restrictions, manage the tyrosine levels, and prevent the metabolic crisis. So the rarity of the disorder has meant that each new cases provided valuable insights into the variability and full spectrum of clinical manifestations associated with the HPD deficiency. So thus, the history of Hawkinsinuria is marked by the progressive elucidations of these clinical features through concerted research effort over several decades. So now we will hear about the causes of Hawkinsinuria by Suhana.
Hawkinsinuria is an inherited disorder that is characterized by the inability to break down the amino acid tyrosine. It is caused by specific mutations in the 4-hydroxyphenylpyruvate deoxygenase (HPD) gene that encode for the enzyme HPPD and oxidoreductases that catalyze the reaction of 4-hydroxyphenylpyruvate to homogentic acid in the tyrosine catabolism pathway. Heterozygous missense mutations that arise in the HPD gene predicting the amino acid valine to methionine change at codon 212 and the amino acid alanine to threonine change at codon 33 were found in patients with Hawkinsinuria. This alteration in its structure and activity causes the accumulation of 4-hydroxyphenylpyruvate in the body and its conversion to an abnormal metabolite, which is 2L-cysteine 4-dihydroxycyclohexyphene-1 acetic acid, known as Hawkinsin. Patients with Hawkinsinuria are known to excrete this metabolite in their urine throughout their lives, which is a hallmark of this disorder. Now let's turn to Rameshni, who will explain the mechanism behind Hawkinsinuria.
Moving on next to the mechanism of Hawkinsinuria. Hawkinsinuria is caused by a defect in the metabolic pathway of tyrosine due to the mutation in the gene encoding the enzyme 4-hydroxyphenylpyruvate deoxygenase (HPPD). This is the normal metabolism of tyrosine. Tyrosine is an amino acid that undergoes several steps to be broken down into acetoacetate and fumarate. In the second step of the metabolism of tyrosine, the conversion of 4-hydroxyphenylpyruvate acid into the homogenistic acid requires the enzyme of 4-hydroxyphenylpyruvate deoxygenase. Mutation in the HPPD gene will reduce or alter the activity of the HPPD enzyme. Due to this reduced activity of the HPPD, the 4-hydroxyphenylpyruvate is not efficiently converted into the homogenistic acid. Instead, it is converted into an abnormal metabolite known as the Hawkinsin through a poorly understood reaction. Hawkinsin is a mean hydrogen positive, a common test that used to detect the amino acid and protein with a free amino group. Hawkinsin is excreted in the urine, leading to the characteristic biochemical finding of Hawkinsinuria. These defects in the metabolism will lead to a protein metabolism disorder called Hawkinsinuria. The buildup of Hawkinsin and related metabolite can lead to the metabolic acidosis characterized by an imbalance in the body acid-base status. Now, let's move to Sazana, who's with a family affected by Hawkinsinuria.
One key indicator of Hawkinsinuria is an unusual odor in the urine. Symptoms often manifest in infancy. Parents may notice their child struggling to gain weight, appearing irritable, or experiencing frequent episodes of vomiting and diarrhea. More concerningly, these early signs can escalate to metabolic acidosis, where the body produces too much acid or the kidneys fail to remove enough acid, which can lead to fatigue, and if untreated, can become life-threatening. With me, Jessica, parents of a child of Hawkinsinuria.
Firstly, we noticed that something was wrong when our baby's urine had a strange odor, like we usually smell in a swimming pool. She also had trouble gaining weight and seemed to be in pain frequently. She was often irritable and had episodes of vomiting and diarrhea. We know that something wasn't right and sought medical help.
Parents like Jessica need to stay alert for these signs and collaborate closely with healthcare providers. Now, let's pass it to Nadia, who will talk about the current treatments available for the condition. Nadia?
Recent studies have highlighted the importance of early detection and intervention. Infants diagnosed through newborn screening programs can begin treatment promptly, significantly improving outcomes. The primary method remains a low-protein diet to reduce the intake of tyrosine, supplemented with ascorbic acid. This vitamin aids in detoxifying harmful compounds that accumulate due to the metabolic defect. However, new pharmacological treatments are also explored that could further alleviate symptoms, improving quality of life for those affected. Patients living with Hawkinsinuria are encouraged by these developments. Support groups and specialized dietary plans play a vital role in handling this condition. As research continues, the medical community remains hopeful for more breakthroughs. For now, early diagnosis and adherence to dietary guidelines remain the key of treatment. That concludes our comprehensive report. Stay with us for more breaking news updates as they come in. Now, back to our regular programming.